recording and whiteboard have not been working today. All right. Now we're going to look at the mean and standard deviation. We remember we've done some work where we calculated the mean and we calculated this. Can you hear me still? Because my screen's blank. Can you hear me?
Yep.
Okay, so I will keep talking when the screen goes blank, but this is what happens when I try to record the whiteboard. Something's not working on my computer. So I'll just stop writing for a second. You remember we calculated the mean and standard deviation. Okay, let me give you an example, all right? You could probably write this down as I speak. If the mean is 50 and the standard deviation is 10, what does that tell you about the distribution? If the mean is 50 and the standard deviation is 10, well, generally in a normal distribution, almost 100% of scores will lie between 3 standard deviations above and 3 standard deviations below. Not quite 100%, actually, it's 99.7%. So that's very close to 100%, but it leaves a point, it leaves out a 0.3%. Now, if I were to just go up 1 standard deviation and down 1 standard deviation, right? So in here, the screen's blank again, 50 and 10. So when it comes on, I'll just quickly write 60, 70, 80, 40, 30, 20. Can you see that?
No, I can't see it, sir.
Okay, you can't see my screen? All right.
Yep.
Let me share my screen. Something's wrong with share screen at the moment. That's because, let me share the screen again. It says I am presenting. Hang on. Let me stop presenting and then restart presenting. Present. And share. And let's go back to, can you see that now?
Yep.
Are you able to see that?
Yep.
Okay, good. Now, if the mean is 50 and the standard deviation is 10, this indicates that about 99.7% of scores are between 20 and 80. Where do I get 20 and 80 from? Where do I get 20 and 80 from? Well, we get 20 and 80 from going down 3 of these and up 3 of these. 3 10s are 30. So if we go down 30, we get to 20. If we go up 30, we get to 80. So if I ask a question, what's the probability of getting a score somewhere between 20 and 80? What will your answer be?
99.7.
Yeah, 99.7 or 0.997 or 99.7%. Correct. Now, each standard deviation is equivalent to 1 Z. A Z value is the number of standard deviations. Number of standard deviations. So this is like saying this formula here was the mean down 3 standard deviations. Does that make sense?
Yep.
And this one was the mean up 3 standard deviations. Okay. Well, that is 99.7% when we go between 3 and below, 3 and above. The total area underneath this curve is 1. 1 represents probability. The total area underneath the right half, total area under the right part of the graph equals 0.5. That's the total area. That's if we keep it going. The total area under the left part of the graph is equal to also 0.5. So to the right-hand side of the mean, everything to the right side is 0.5. And everything to the left side is 0.5. So here's a question. What is the probability of getting a score less than the mean?
0.5.
0.5. Good. What is the probability of a score greater than the mean?
0.5 as well.
0.5. Now, what I've been doing here is using x values. Now, remember what I mentioned, Z? Z is the number of standard deviations. This question can be converted into the probability. I'll just going too slow. All right, I'll stick with that. The probability of a Z score being less than or equal to 3 and -3. So this equation here can be Z or it can be X. Now, X are the real numbers. X is the scores, 20 to 80. But we can convert 20 into a Z score. And what I'll do is I'll just put under here, that's the Z score of 0. That's the Z score of 1. That's the Z score of 2. And that's the Z score of 3. That's the Z score of -1. That's the Z score of -2. That's the Z score of -3. Remember, Z score represents the number of standard deviations. The number of standard deviations. One standard deviation above is 60. 2 standard deviations above is 70. 3 standard deviations above is 80. 1 standard deviation below is 40. 2 standard deviations below is 30. 3 standard deviations below is 20. Is that clear?
Yep.
So here I've got a -3 in that bracket, and over here I've got a 20. I use a 20 if I have an X here, but I'll use a -3 if I have a Z there. So depending what letter we're using in the middle, if it's an X, it means the real score. That's what X is. But if it's a Z, then it would be the mean is 0 and the standard deviation is 1. So if it's a Z, we would use 0 for the mean and 1 for each standard deviation above. Okay, this says the probability of X is less than or equal to 50. What could I have instead of X if I was to put Z? What would I say here? Instead of X being less than or equal to 50, we could change that into Z is less than or equal to?
0.
0 is correct, yes. So the probability of a Z being less than 0 is equal to 0.5. The probability that Z is greater than 0 is 0.5. That means to the right hand of the mean, this is to the left-hand side of the mean. All right, I'm going to try to scroll up if I can. Wait a minute, that's getting smaller. All right, that's good enough. Okay, I want to go now back to the graph, and I want to say 1, 2, 3, 1, 2, 3. That's 50, that's 60, that's 70. All right. let's only go one standard deviation above and one standard deviation below. Remember, now I'm doing one standard deviation above and one standard deviation below. So instead of 20 to 80, I'm going to go from 70 up to, something's wrong, that should be a 40. I'm going to go from 40 up to 60. Okay, here I had 99.7%. Well, we've got another number here. There's three numbers that this chapter 16 will ask you to remember. It will not be in any notes. You have to remember this. It's 34% between one below and the mean, and there's another 34% between the mean and one standard deviation above. So to get a score between 40 and 60, if we say, what's the chance of getting a score between 40 and 60, we will say 68, 68%. All right. It's a magic number, 68%. We don't get that. We don't make that up. That happens to be the integral from 40 to 60 of whatever that function of x is, and it is approximately 0.68. Approximately 0.68. The integral from 20 to 80 for our function of x is approximately 0.997. So that's the area under the curve. If we had the z curve, it would be between -1 and +1 if it was actually, can I just put a z there just so it makes it easier for you to understand? Oh, that's -1. I want from -3 to +3, that would be about 0.997. The integral from -1 to +1, if we had the function in terms of z, will be 0.68. All right. So the area under the curve is our probability because the total area is 1. What would I write here for 40 to 60 using a z? What would I write here? Between what numbers?
-1 and 1.
Good. And now I'll just do the other one while I'm talking about this. The other one is when we go to 2 and to +2. We have a bigger area. This area is 47.5%. This area is 47.5%. Together, the probability from -2 to +2 is about 0.95 or 95%. There's the three numbers. You have to remember that number, 68, that number, 95, and that number, 99.7. You have to remember it because you cannot take it into the test written down, and it's not written down on the formula sheet. So you have to remember that. Okay? By the way, nothing stopping you from during your reading time. During your reading time, look for the questions, and you can, when you start the tests, there's nothing stopping you from straight away writing 68, 95, and 99.7 on that question for reference if you think you're going to forget that later. Sometimes it's better to have some numbers you want to write down straight away and use that later. Okay, what will this probability be if I talk in terms of x? If I put an x here, what numbers would I use here to be 95%?
30 and 70.
30 and 70 here. Okay, these questions so far have been symmetrical. I've used one below and one above. Now, from this point, we can get a bit creative. All right, there's nothing stopping us from, I'm going to try to, I can't scroll up. Hang on, I'm trying to scroll up. There it is. All right. Okay, here's a creative question. All right, think of this. What is the probability of getting between 40 and 70? What is the probability of getting between 40 and 70?
Is it like 81.5?
What did you get?
81.5.
Let's find out. That's one standard deviation below. That's the Z, that's the X. That's two standard deviations above. So in here we've got 34%, and in here we've got 47.5%. So yes, you'd be correct if you add those together and get 81.5%. Well done. Okay, good. All right, let's stick with getting creative for a moment. Oh, I didn't want that. Okay, let's now change the question and say, what's the probability of getting a score between 20 and 30? What's the probability of getting between 20 and 30? There's 20. There's 30. We want the probability of this area. How'd you go?
I got 1.25.
1.25. You got 1.25, huh? Okay, let's find out. Well, we know that the area from here to here is half of 99.7. 99.7 divided by 2 is 0.49. Is that 17? 8, 5. Okay, so that is an area of 0.4985. And in here, we said it was 47.5, yeah? So therefore, we want 0.4985 minus 0.475. So 5 take 0 is 5. 8 times take away 5 is 3. Did I make a mistake?
No, I think I was wrong, sir.
Huh?
Yeah, I was wrong. I put 97 instead of 99.7%.
Oh, okay.
Yeah.
So we got 2.35%. No, but thank you for trying. But you see where you went wrong.
Yep.
Yeah.
Yep.
There was something like a question recently that we had to do that said, like this question here, what's the probability of getting a score bigger than 80. There's 80 there, right? Good luck. No, it wasn't greater than 80. But anyway, what's your answer? Okay, now bigger than 80, this is 0.4985, and after all of that is 0.5. So if we take 0.4985 from 0.5, we will get I think. What will we get? 0.0015? What do we get? Five, 1, 0, 0. Yeah. Or that is 0.15%. You remember there's a 0.3% difference here. You see, from the 99.7 is only between -3 and +3. We get 99.7% in between here and here. Therefore, there's a 0.3% split up into two parts, 0.15% over here and 0.15% over there. I think the test had a question like this one. What's the score greater than 70? All right, try that one. Score greater than 70. Now, between 0 and 70, you've got a 47.5%. So what will it be after 70?
2.5.
0.5 minus, see, it's 0.5 bigger than 50, and it's 0.475 between 50 and 70. So after 70, it must be, oh, did you say 2.5?
Yep.
Yep, that's correct. 0.475 equals 2.5% or 0.025. Okay, if you used a calculator, it's more likely closer to 0.0228, but it's okay. These are approximate, right? These are not exact. So we've been looking at how the mean and the standard deviations work and how Zs can combine with them. I like to just save this image and start a new one. Maths method. Today's the second. All right. And I'd like to just clear this. Well, I'm surprised it's working this afternoon. It has not been working all day, this whiteboard. Now, have you got your sign? Have you got your calculator there? I want you to go to your graph function and put in a fraction 1/2 pi times e to the power of negative x squared over 2. I want you to graph it. Make your x, your minimum x, go across to say -5, and make your maximum x go across to say +5. Make your minimum y go down to -1. Make your maximum y go up to +1 because it doesn't go very high. So we just want your from -5 to 5, from -1 to 1. That's 1. That's -1. -5. 1, 2, 3, 4. Okay. What does your graph look like?
So
Are you
how do
having?
how do you
Huh?
do the minimum and maximum values?
Oh, okay. Look, let me open my calculator here. And I'll go into the menu box and go to the graph function. And can you see a square that looks like that?
Yep.
All right, press on that. And then you have your max x minimum to be -5, your x maximum to be 5, your y minimum to be -1, and your y maximum to be 1. That should do.
Yep, it will. Thanks, sir.
Does it look like this?
Yep.
Okay, you see, this is the actual function of the normal distribution. This is the actual function where this is 0, your mean is 0, and each unit is your standard deviation. So if we were to integrate this formula from -1 to 1, if we were to integrate that formula, so if you were to say define back in the main menu, if you wanted to define that function, when you integrate that function, you will get about 0.68. Okay. That's something you can do in your own time. Okay. The next part of the lesson is very tricky, the next few minutes. Do you remember transformations of graph? You remember that?
Yep.
Okay. I want to stretch this out so that we don't have 1. I want to stretch it out so we have 10, 10, 10. That's 10, 20, 30. -10, -20, -30. How do I stretch that out? How do I make it go a factor of 10 from the y-axis? How do I do that? Do you remember?
Not too sure, sir.
Okay. We have to take this x value here, take the x, and divide it by 10. If you divide x by 10, you will stretch it out by a factor of 10. If you multiply it by 10, you squash it by a factor of 10, and this would become 0.1, 0.2, 0.3. We don't want that one. We want that one. So put a 20 underneath there. Put a 20, not a 2, and then regraph it. But change your x minimum to -50 and your x maximum to 50, because we're going to stretch out the graph, and tell me if it worked. Did that work?
Yeah, I did, sir.
Do you have 10, 20, 30 now instead of 1, 2, 3?
Yep.
Okay, good. Now, but the thing is, what we're going to do also is, at this point, I want to also take this theta. If I stretch it out, I want to squash this down by 1/10. If I stretch it out by a factor of 10, I want to squash this down by a factor of 10. So how do I, instead of making that go up high, I want to drop that down by a factor of 10, 1/10 of that. So where do I do that? Right? That's the number in front. You see, if we have y equals, say, 3x plus 5, if I put a 1/10 here, then I squash my y values by a factor of 1/10. To the x-axis. You see, we're squashing it by a factor of 1/10. So I'm going to put a 10 there. So I want you now to put a 10 in front of the √2 and regraph it. It won't go up as high. How'd that go?
Yeah, it works, sir.
Okay, good. Now, one more thing. I don't want this to be 0. I want it to be 50. So how do I slide my graph across, all the way across, 50 across?
Minus 50 at the end, right?
Whoa, there is going to be a -50. Where do we put the -50?
At the end of the graph.
No, with the x.
Oh, okay. Yeah.
All right, so instead of x squared, it's going to become x minus 50 squared. You see? By sliding, just the x has to be slid. So it's just the x coordinate needs a -50 there. And it still needs to have a square. So now put a -50 in that bracket if you can with the square, but change our minimum and maximum. Now we'll have to go from, we're moving across 50. So now our minimum x will be, say, from negative, oh, that's just going to be 0. We want just our minimum to be 0 and our maximum to be 100, because we're going to slide it across 50. And this will become 80. That will become 70. That will become 60. That will become 40. That will become 30. That will become 20. Okay? something you can do later. Here's a question, all right? Here is a question. What is that function? What does that function represent?
Normal distribution.
Good. It's the normal distribution where the mean is 0 and the standard deviation is 1. Okay. What is that?
Normal distribution, but the mean is 30.
The mean is 30, yes.
Standard deviation is 10.
Close. Don't forget that 2 was already there.
Oh, 20.
No.
Oh, 5.
5 is correct. Okay. Now, what if I ask this question? What's the probability of getting a score between 25 and 30?
34%.
It is correct, 34%. Okay. Enough for one lesson. All right. All right. Don't worry too much about questions that talk about finding the variance of a, at the moment. By the way, the variance, if the standard deviation is 5, what will the variance be? The variance is standard deviation squared, which is 25. The variance is just the standard deviation squared. So our earlier question, our variance was, for the first part of the lesson, 100. Okay. So sometimes you might see the word variance, which is simply the square of the standard deviation. So if ever you see the variance, then it's the square of the standard deviation. I've discussed some of the work that you might be looking at in 16A, and yes, there was one more point I wanted to make, and this is a very easy point. Remember our first question, let's take 70. What's the Z value for 70? What was our Z value for 70?
2.
Yes. 70 is X. So if we say, if X equals 70, what is the Z value, all right? If X equals 70, what is the X value? There's a little formula called Z equals X minus mean over standard deviation. So it's getting 70 minus the mean, that's called the deviation. That means 20. And we divide that by 10. How many 10s in 20? And you get 2. All right. So there's this little formula in that orange box that I wanted to also talk about this lesson. It is just a little formula that helps you work out what does Z, converting Z and X backward and forward. But if you understand how you get Z, you will understand how to convert from X to Z. It's the deviation. From 60 to 50 is 10, and 10 divided by 10 is 1. So you're 1 standard deviation. That is on the middle of page 663. And so we've just, I would suggest 16A and 16B. However, the work I've done this lesson covers 16C as well, and it covers 16D as really the theory of what I've done today covers just about the entire chapter 16. I do want to talk a little bit more next lesson about the mean and the standard deviation as being, so that's next lesson. I just want to do a little bit about that next lesson. Okay, so I'd like you to practice chapter 16. I suggest do a couple of questions from each of the exercise, A, B, C, D, but not E. 16, A to D. This theory helps you with 16, A to D. Okay. How are you feeling about this right now, about chapter 16, A to D?
Better than before.
Yeah, no, that's important because we still haven't had the exam. These lessons, I did say in class, we have not had these lessons. And I alerted last week we are going to be doing chapter 16. But since people are missing the lesson, I'm hoping that they watch the recording, because what we did today is absolutely necessary for every question. And you might recall a question before I wrap up. I just want to recall a question in one of the tests, and it said this. Where was it? Let me just go to it. Okay. The question said, let the random variable x be normally distributed with a mean of 139, the mean 139.5, and the standard deviation of 6.2. And it said, let Z be the standard normal random such that Z, and then it's got this squiggle, is a normal distribution, and they've got the mean as 0 and the standard deviation of 1. So 0, 1 means the mean is 0 and the standard deviation is 1. So they're just saying Z is the number of standard deviations. So when they say Z here, and it says find the probability that X is greater than 151.9, 151.9. Now, knowing what we've done today, what will our answer be? X is greater than 151.9. What is 151.9? Where is that? What Z score is 151.9?
I think it's 2.
Sorry?
I think it's 2.
Yes, because 139.5, if you go up 6.2, you get 145.7. And then if you go up 6.2, you get 151.9. No? Yes. Okay, there it is, 151.9. So they want the probability of getting a score greater than 151.9. So what will our answer be?
Uh, 2.5.
Correct. 2.5%. Or 0.025. It doesn't matter if you answer decimal or as a percent. Then they said the probability of a score is less than B is the same as the probability of a Z being greater than 1. Okay, being less than B is the same as a probability of a score greater than 1. I'll let you think about that one. That's a challenge question. I won't answer that until the next lesson. That's a little bit of a game. You could try and see if you can solve that little problem. It's tricky, but it was worth 2 marks. This was worth 1 mark. No, this one was worth 2 marks. Remember, this one's a Z. This bracket's Z. This bracket is X. So that B value has to be a normal score, like our 50. Probability Z greater than 1. That's this area here. We want, that's this area, isn't it? That's Z greater than 1. Where can we get that area? Less than a certain number. Where's that area? Repeat again on the left side. This is the greater side. That's a bad graph. My 1 and -1's not too good. Ooh. We get that area over here, less than -1. By the way, the probability of a Z being greater than 1 is the same as probability of Z less than probability of Z less than -1. We get the same areas. Having a Z greater than 1 is the same as the probability of it getting a Z less than -1. Having a score greater than 60 is the same as having a score less than 40. Having a score greater than 147.5 is the same as having a score less than that one there. All right, that's going to be the number for the answer. This is the answer here. That's all right. I'll talk about that again next lesson. I'll start the lesson with this question, and then we'll talk about the mean and the standard deviation as being NP and PQ. Next lesson, we're going to be talking about exercise 6E, 16E. All right. I've used up full time. That's all we've got for you today. Have a happy afternoon.
Thanks, sir.
All right.
Thanks, sir.
Good on you. Study hard.